So emulsion is a type of dispersion system, or we can say it is a general class of two-phase system of matter known as colloids. An emulsion comes from a Latin word to milk, whereas an emulsion is a mixture of two or more liquids that is normally immiscible. If we talk briefly, we can say that the emulsion is a dispersion in which the dispersed phase is composed of small globules of liquid distributed throughout the vehicle which in which it is immiscible, or we can also say it is a thermodynamically unstable system. If we talk about dispersion phase and dispersion medium, the oil droplet or the droplet phase that are dispersed in a liquid is called as dispersed phase, whereas the liquid in which that particular droplet is dispersed throughout the medium is known as dispersion medium. So normally there are two types of emulsion, oil in water and water in oil. The oil in water is in which the oil droplet is dispersed in water, whereas in water in oil, the water droplets is dispersed in oil. So we can see many applications on our daily life, such as egg yolk is an emulsion, cream on espresso is an emulsion, whereas butter is also an emulsion of water in fat. So what are emulsifiers? These are the substances that are added to the emulsion to prevent the coalescence of the globules of the dispersed phase. They are also called as emulsifiers or emulsions. So they follow three basic mechanisms. Number first is the reduction in the interfacial tension to achieve a thermodynamically stable emulsion, and second is to form a rigid interfacial film, and the third is by the formation of the electrical double layer electrical barrier to approach the particles. So pharmaceutically acceptable emulsifiers can be of following categories. They should have the following compatible properties. They should be stable, they should be compatible with other ingredients, they should be not toxic, they should have less odor, less taste and color. They should not interfere with the stability of the or efficacy of the active agents. So normally we classify emulsifiers as synthetic surface active agents, multimolecular films, and particulate films. So if we talk about instabilities, the reason for instabilities can be understood by the nature of the immiscible phase and their interfacial properties. When the two liquids are not miscible in each other, they are will separate into polar and non-polar phase, and that can cause instability in that particular emulsion. That can be of physical, chemical, and miscellaneous type. In physical instability, we will study about flocculation, creaming or sedimentation, aggregation of coalescence, breaking, or phase inversion. Whereas in chemical instability, we will study about pH changes, oxidation, deterioration of light, deterioration by temperature or hydrolysis. Whereas in miscellaneous instability, we will study about microbial contamination or adverse storage conditions. So what is physical instability? The physical instability is in which when the system is unable to resist the changes in the physiochemical properties over the time. So it will convert into following types. Number one is flocculation. When the neighboring globules come together to each other and form colonies in the continuous phase. This aggregation of globules is not visible because it is the initial step that leads toward the instability, and after which it will lead toward the creaming. So you can see that the follicles will come together and make start flocculation. So the reversibility of the flocculation can be depend upon the interaction between the particles, and it can be determined by the chemical nature of the emulsifier, phase volume ratio, and the concentration of the dissolved substance, especially the electrolytes or the ionic emulsifiers. So how can we prevent flocculation? It can be prevented by globule size distribution, charge on the globular surface, or the viscosity of the external medium. So the globule size distribution, uniform sized globules can prevent flocculation that can be achieved by the proper size reduction, whereas the charge on the globule surface can also exert as repulsive forces on the neighboring globules. This can be achieved by ionic emulsifying agent or electrolyte, whereas the viscosity of the external medium is, if we increase it, then the globules become relatively immobile and the flocculation can be prevented. This is obtained by adding viscosity modifying agents such as thickening agent that can be hydrocolloids or waxes, or uh, flocks slowly move either upward or downward, and it can lead towards creaming. So what is creaming? Creaming is the concentration of the globules at the top or the bottom of the emulsion. That droplet size can be of 1 millimeter. It can be observed on the account of the difference in the individual globule. And we can say that it is a reversible process. How it is a reversible process? Because cream can be redispersed easily by agitation. This is possible because the oil globules are still surrounded by that protective sheet of the emulsifier. So types of creaming, as we have already discussed, it is upward creaming or lower and downward creaming. In upward creaming, the dispersed phase is less dense than that of the continuous phase, and it is normally occur in oil and water emulsion. You can see this is upward creaming, whereas in downward creaming, the dispersed phase is heavier than that of the continuous phase, and it can be due to the gravitational pull. The globules can settle down, as you can see in this diagram, and it mostly occur in water and oil emulsions. So how it affects creaming, and this can be determined by the Stokes law. Stokes law influence creamings a lot, and that can be determined by V is equal to D2 PS minus P naught multiplied by G divided by 18 and naught, where as V is the terminal velocity that can be in centimeter or seconds, T is the diameter of the particles of the dispersed phase in centimeter, P naught is the density of the dispersed phase, Ps is the density of dispersed phase, G is the acceleration due to gravity, whereas N naught is the viscosity of the dispersion medium. So how creaming is influenced? It can be influenced by globular size, viscosity of the dispersion medium, difference in the densities of the dispersed phase, and the dispersion medium. How we can prevent creaming? Creaming can be prevented by the reduction in the particle size, increase in the viscosity of the external phase, by the addition of thickening agents such as methyl cellulose, tragacanth, sodium alginate, by adjusting the continuous phase and the dispersed phase densities to the same value in order to eliminate the tendency of the creaming. Whereas we can also make the densities equal oil soluble, adding oil soluble substances such as bromophore or beta bromophenylene. So what is aggregation or coalescence? Aggregation in which the dispersed particles come together and they do not fuse again, and it can lead towards the coalescence, which is the process by which emulsified particles merge to form a large particle. This coalescence can be observed due to insufficient amount of emulsifying agent, altered partitioning of emulsifying agent, incompatibilities between the emulsifying agents. So coalescence can take place in two steps, which is in first step that dispersed phase droplets merge and join to form a large particle, and that will simply be covered by agitation. But when the two droplets come in contact and they become a flocule, the thin liquid layer around that is composed of continuous phase and adsorbed emulsifier are also formed between them. Coalescence begins with the drainage of these films as the droplets approaches to one another, and that film is ruptured and it forms a larger globule that causes the coalescence. So how we can prevent coalescence? We can prevent coalescence by the use of mixed surfactant films, by the use of laminar liquid crystalline phase, and can use polymeric surfactants. What is breaking? Breaking is the destroying of the film surrounded by the particles, that is separation of the internal phase and the external phase by the breaking of the emulsion. So it simply indicates that the oil is separated and the aqueous phase is separated, and it is simply an irreversible process. If we mix them together, it will fail. It cannot be redispersed. In breaking, the protective sheet around the globules simply destroyed, and the oil tends to coalesce. So in you can see this is an emulsion, that this is a pure emulsion, and in this you can see that the oil phase is separated and the aqueous phase is also separated. So what is phase inversion? This involves the changes of the emulsion from oil and water to water and oil, or vice versa. If we have prepared one emulsion, that is oil and water, and the final emulsion turn out to be water and oil, so we can say that there is some kind of instability in that particular emulsion. So as we know that it is a physical instability, it can be due to by the addition of an electrolyte, such as by the addition of calcium chloride into an oil and water emulsion, formed by the sodium stearates can convert it into a water-enol emulsion. Or we can also say it can be due to the change in the phase volume ratio or by the temperature changes. So how we can minimize this? We can minimize is by the use of a proper emulsifying agent or keeping the concentration of the dispersed phase between 30 to 60% or storing the emulsion at a cool place. So, what are chemical instabilities? If we talk about chemicals instabilities, then they are reactive and decomposition ability of a substance or a species in that particular emulsion. So, what the type of the chemical instabilities? These are oxidation, degradation by light, by temperature, hydrolysis, or change in pH. So, what is oxidation? Many of the compounds are subjected to auto-oxidation upon the exposure to air. So, when that particular lipid are that are sensitive to attack, they are exposed to oxidation that result in decomposition. Upon auto-oxidation, unsaturated oil such as vegetable can oil give rise to foul odor, darkening. Its viscosity can increase, can lead to awkward taste or appearance or on the other hand, in mineral oil and related saturated hydrocarbons are also subjected to oxidative degradation, and that can only occur in rare circumstances. So, autooxidation is a free radical change. It can be inhibited by the absence of the oxygen, by the free radical chain breaker, or by a reducing agent. We normally add antioxidant to prevent the oxidation process. That can be gallic acid or propyl gallate, or it can be ascorbic acid for oral preparations, sulfites for oil products, L-tocopherol for pharmaceuticals and cosmetics. Degradation can be occurred due to light that can alter our emulsion. Deterioration can be occurred due to the temperature that can cause the polymeric change in the properties and the influence of increased temperature, or hydrolysis can occur, which is a chemical reaction in which a mobile molecule of a water breaks into one or more chemical bond. pH change. pH can alter the emulsion. Lowering of the pH is used to demulsify the chemically stabilized emulsion. So in this, you can see that is a stable emulsion having a normal pH. But when the pH is reduced, it is converted into an unstable emulsion. The next is miscellaneous instabilities, in which we will study about microbial contamination and adverse storage condition. In microbial contamination, most emulsion are sensitive to the growth of bacteria, yeast, and molds because of emulsifying agent are not suitable for that particular emulsion. That can be due to the decomposition of the emulsifying agent, contamination of the aqueous phase, and it can also produce a rancidity due to oil or the density of oil soluble vitamins. So, to prevent microbial contamination, we normally add antimicrobial agents such as benzalkonium chloride, cetyl trimethyl ammonium bromide, chlorohexide, and salts. Whereas we can also add preservative to prevent the microbial contamination that are a mixture of para-hydroxybenzoyl, methyl ester, and propyl ester, and that are particularly effective against the mold, ester, and bacterial prevention. Last but not the least is adverse storage condition. In adverse storage condition, it can also lead towards the instability of the emulsion. The adverse storage conditions can depend upon the increase or decrease in temperature that can cause the breaking of the emulsion, and it can also alter the viscosity of the particular emulsion. Or freezing. Freezing can also cause a drastic change in that particular emulsion. It can form crystals in that particular emulsion and the globules that can lead toward the breaking of the emulsion. So that was all about my presentation. These are the references. Thank you so much.